Hello, everyone. This is Alex, and welcome to the mathleague.org YouTube channel. We'll be talking about Target Problem 6 from the February 2021 high school test release 12105. All right, so in this problem, as you can see, we want to let x and y be real numbers such that their sum is 6 and x over y plus y over x is equal to 10, and we're tasked with computing x, y. Now, how do we usually solve systems of two simultaneous equations and two unknowns? Now, we would just like to be able to reduce them to linear equations if they aren't already, but unfortunately, it doesn't look like it'll be that easy. So, can we simplify one of our equations somehow so that we can just plug in the first and get our answer that way? Bingo. In fact, as we'll see, we don't even really need to figure out what x and y themselves are at all at any point, only what their product is. Okay, so we know that x over y plus y over x is 10, right? Well, what does that prompt us to do as our very first instinct? That is, how do we add fractions together? Right, we take a common denominator. So we'll want to write x over y as x squared over xy, multiplying both the numerator and denominator by x to get the common denominator of x times y. And similarly, we'll want to write y over x as y times y, that's y squared, over x times y. Great. So now we have x squared plus y squared over xy equals 10, or a nice and simple x squared plus y squared equals 10xy. Only one problem. How do we use the fact that x plus y equals 6? Where does this ever come up, and how do we extract the value of xy in the end? Quadratic formula doesn't seem to work too well here, because we get x squared minus 10xy plus y squared equals 0, and that doesn't look too much like any quadratic that we know. In fact, if we tried to square this, we couldn't, because only x squared minus 2xy plus y squared resolves as a perfect square, which is x minus y squared. Now, what about completing the square? And this is going to be our first solution of 3, completing the square. Doing so, completing the square will give us x squared minus 10xy plus, what is that? We added 10 divided by 2, that's 5. Square that, you get 25. X squared minus 10xy plus 25y squared equals 25 minus 1, that's 24. 24y squared. You factor the left-hand side as a perfect square. You end up with x minus 5y squared equals 24y squared. Square root both sides. That's, well, remember that the square root of x squared is defined as the absolute value of x, not just x. And we'll proceed to write x minus 5y equals square root of 24 times y. That's 2 root 6 times y. And also the negative counterpart, negative 2 root 6 times y, right? Because of that definition. And now we have to solve these two equations separately. X minus 5y equals 2 root 6 times y, and x minus 5y equals negative 2 root 6 times y to obtain, well, x equals 2 root 6, 5 plus 2 root 6 times y, and also x minus 5y equals negative 2 root 6 times y, also x equals 5 minus 2 root 6 times y, respectively, right? But now, which one of these actually makes sense? In other words, can we eliminate one of the possibilities right off the bat as being absurd or not fulfilling the conditions of the problem? Well, not exactly. It seems like both work perfectly fine. So let's just try out the first one. If x equals 5 plus 2 root 6 times y, then we could plug that into x plus y equals 6. And we get 5 plus 2 root 6 times y plus y equals 6, which tells us that 6 plus 2 root 6 times y is equal to 6, and therefore y should be equal to 6 divided by 6 plus 2 root 6. Okay, now what? Well, at this point, we'd have to rationalize the denominator just to get rid of that radical in there. And if you remember, we have to multiply both the top and the bottom by the conjugate, which is just the denominator with the sign reversed, sign flipped. So that would be the same as multiplying by 6 minus 2 root 6. And in doing that, we'll just write it like this and then expand out and simplify. And once we do that, we would obtain, we'd expand it. We get 36 minus 12 root 6 over 36 minus 12 root 6 plus 12 root 6 minus 2 root 6 squared. Well, the 12 root 6's cancel out. And then 2 root 6 squared is 24. So you get 36 minus 24, that's 12, which is just 3 minus root 6. All right. So the problem asks for x, y, and that's just, well, what's x? X is 6 minus 3 minus root 6. That's the y we found earlier. That's 3 plus root 6. Good. So Now we get xy equals 3 plus square root of 6 times 3 minus square root of 6. You expand one more time. You get 3 squared minus 3 root 6 plus 3 root 6 minus root 6 squared. That's 9 minus 6. 3 root 6 is cancel out. 9 minus 6 is 3. And we're done with that approach. That was solution 1, and what I'm going to present as 3 different solutions. See, I really like this problem in particular because it's so multifaceted. There's no one correct or singular way to solve this problem. And in fact, there's so many different ways and perspectives to look at basically all of these. Now we're going to move on to solution 2 now. So in this solution, we'll be manipulating the seconds of our given equations, the x over y plus y over x equals 10, more algebraically, where we do the same as before, basically writes x squared plus y squared over xy equal to 10, same as before. Only now we just take a look at the x squared plus y squared equals 10xy and try to simplify the left-hand side, that x squared plus y squared, so that it contains an x plus y term somehow. Well, we can't exactly apply the difference of squares formula because that only works for x squared minus y squared, keep in mind. So that's out. Well, what do we do from here? Well, just out of curiosity, I don't exactly know what else to do, so I want to see what happens when I try squaring x plus y. Okay, well, remembering our FOIL, that's x squared plus x squared plus xy plus y squared. That's x squared plus 2xy plus y squared, which is just x squared plus y squared plus 2y. Wonderful. We've just gotten an expression that has an x squared plus y squared in it, but it also has a 2xy. But that's no problem because we just saw that x squared plus y squared equals 10xy. And so, well, that just gives us x squared plus 2xy plus y squared. That's 12xy, but that's also x plus y squared. That's 6 squared. That's 36. Actually, type that. That's no problem at all. Cool. All we have to do now is divide by 12. So we get xy equals 3 immediately without even having to calculate x and y like before. Isn't that fantastic? Now, finally, I want to go through one more solution. Solution 3. Solution 3. Instead of doing any real algebraic manipulation like before, well, I should say we're still manipulating just in a different way. You may notice that we're summing an x over y and a y over x to get 10, which is constants. It doesn't have any variables in it. And you may have also cleverly noticed that y over x is just the reciprocal of x over y. So what can we do with that? Well, if we were to, let's call the value of x over y, let's call that t, right? And so what does that make y over x? Exactly, 1 over t. So what we end up with is the equation t plus 1 over t equals 10. Great. We know what to do this. We turn it into a quadratic. Multiply both sides by t, and you get t squared plus 1 equals 10t, or t squared minus 10t plus 1 equals 0. And now we can apply quadratic formula. Awesome. Now, if you remember what quadratic formula is, that's this following. It's minus b plus or minus the square root of b squared minus 4ac. All that divided by 2a. Well, what's our a? What's our b? What's our c? Now, a is just the leading coefficient. That's the very first coefficient to the very left in front of the t squared. That's 1. B is just the number in front of the t. Well, that's minus 10. T is the constant term. That's 1. Great. So now just plug all that stuff in. You get negative 10 for b. That's just positive 10. Negatives cancel out. Plus or minus. Remember, this produces 2 different solutions for t. You get 10 plus positive 10 plus or minus. Well, b squared is just negative 10 squared. That's positive 100. A is 1, c is 1, 4 is 4. 100 minus 4 is 96. You get square root 96. That simplifies to 4 root 6 because that's 16 times 6. You pull that out. 16 becomes 4 squared, right? And finally, you divide by 2a, which is just 2. You get 10 plus or minus 4 root 6 over 2. That's 5 plus or minus 2 root 6. Remember, we still have the 2 solutions, right? So remember, t can be either one. So what does that mean for our solution? Well, we just solved for x over y, right? Because that's how we define t in our substitution. So x over y is equal to either 5 plus 2 root 6 or 5 minus 2 root 6. Now, it doesn't really matter which one we take. So we'll just do 5 plus 2 root 6. Then we're also given that x plus y equals 6. So just like before, we'll solve for x and y and then multiply them together. Well, that was already in solution 1, so I'm not going to waste too much time covering it again. But we just check that it's 3 again. So hallelujah. We just put down 3 in our answer box, and we are done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.